Let's look at an example header. This is a header that's actually for a C++ class. So I'm going to call this class A, and class A has a couple of attribute values. So there's some integer called value. There's a function called getValue, a function called setValue, and then I want to keep a little bit of a history of previous values. So I'm going to keep an array of size 10. And this is going to be all the pieces that make up my class A. So there's no implementation here, just the structure of the class. So I want to point out a couple of key things that are the most important things of the class in a language independent way. So first of all, we have the class name. Then we have some attributes of the class. So this one's called value. And we also have an array of attributes. So both of these are attributes here. Then we also have two operations, getValue and setValue. One of them returns an int, the other returns void, but takes an integer as one of its parameters. So other important things are the return values, or the actual value of the attribute for the ones that are just static attributes. We also have some parameter values that are passed into operations. And then we have a multiplicity that belongs to this particular attribute. So these kinds of features of the class are things that we'd like to be able to represent. And I want to use a model to specify these object-oriented concepts in a language-independent way. So I want to be able to specify the structure of my class without actually having to write it. So, for example, I'm going to start with my value, one of the attributes of the class A called value, and value is of kind int. So I'm going to specify it value colon is int instead of int space value semicolon. Similarly, for previous values, they're also of kind int, but there's 10 of them, so I'm going to use this syntax to represent previous values. I have a function called getValue that returns an int. So value and getValue here seem to be using the same syntax, even though one of them is a function and the other is an attribute. So you can put parentheses here to remind yourself that getValue is an operation and not an attribute. But in any case, you'll see in a minute why we don't have to have these parentheses here. And finally, we have setValue, which takes an integer input and returns void. And this is what makes up our class A. So I want to point out one thing here, which is that the syntax for the parameter that's passed into setValue is the same kind of syntax that we use for attributes here. That is, I've got the name that I represent in the program as the instance value, in first, colon, int, which represents the type of in. So usually when you would write this as part of your header, you would say int space in for C, or C++. But in my model, I'm using in colon int. So these are two different syntaxes, and the reason for that is that we want to be able to write these operations and attribute values in a language-independent way. And so the syntax for this kind of diagram specifies that you use instance name colon type. So the top bit of this class represents the attributes. And then we separate the attributes from the operations with a solid line. But everything that we see, the attributes plus the operations, makes up the features of this class. And above the features, we represent the class name, A. So the reason that we use a model in this way is that it's fast to sketch. So it's much faster for me to write down these values. And in fact, I may defer figuring out what their types are, and first I'm going to just write down the corresponding concepts of the class, and then I'll fill in the attribute actual types later, or the return values later. So the model's pretty fast to sketch. It's language independent, so I could give someone this picture and they could write a Java class that has exactly the same features, even though the Java file will have a very different syntax from the header file for a C++ class. Finally, I'm still getting a meaningful representation of the concepts. And that goes back to the fact that if I gave someone a picture of this class, they should be able to draw, or they should be able to type out the actual class header file. And again, we're talking only about the structure of the class. I'm not specifying what the meaning of getValue is. I'm not providing its implementation. I'm not telling that when I call set value, I want to overwrite the most recent version of previous values. None of the behavior is specified here, only the structure. And that's what an object diagram and a class diagram allows us to specify, are the structure of our classes.